In late 2025, the Sun unleashed one of the most violent solar storms in recent history. A wave of plasma, billions of tons of charged particles, surged outward from its blazing surface. The kind of eruption that can cripple satellites, scorch atmospheres, and strip the tails from passing comets. But one object, drifting through that inferno, refused to die. It was called 3I Atlas, the third known interstellar visitor ever recorded, and the first to face the Sun this closely. What happened next would leave astronomers staring at their instruments in disbelief. As the coronal mass ejection tore through interplanetary space, most scientists expected 3I Atlas to disintegrate, a fragile relic of ice and dust, utterly defenseless against solar fury. But data from the Solar Orbiter and Parker Solar Probe showed something no one anticipated. The object held steady. Its brightness fluctuated only slightly, its trajectory remained unchanged, and its nucleus appeared intact, as if the storm never touched it. To survive, a direct solar hit like that defied every known model of cometary physics. Even comets from our own system, hardened by countless solar passes, fragment or evaporate when exposed to similar energy levels. But 3I Atlas didn't even flinch. Some researchers suggested it might contain exotic compounds with ultra-high sublimation points, materials capable of withstanding temperatures far beyond what normal ices could endure. Others whispered a more unsettling idea, that the behavior appeared controlled, the course too precise to be purely gravitational. Natural or engineered? No one dared say it aloud on record, but in the corridors of observatories and data labs, the question hung in the air like static before a lightning strike. Weeks after its brush with the Sun, 3I Atlas continued on its hyperbolic escape path, straight past Mars, its closest approach, a mere 12 miles above the Martian surface. That's closer than many of our orbiting satellites. NASA's HiRISE camera aboard the Mars Reconnaissance Orbiter captured high-resolution images of the flyby. For a moment, humanity had the chance to see an interstellar traveler from another star system passing a world we might one day call home, but the images never came. The public release that followed was oddly cautious. Statements, phrased with deliberate neutrality, the data could reveal unusual surface activity. Processing continues. Further review is needed. Behind the careful language, astronomers sensed hesitation. What exactly did those missing frames contain? Did the object appear intact or altered after its encounter with the Sun? Across online forums and even within academic circles, speculation grew. Was NASA protecting incomplete data? Or were they simply waiting for peer review before release? Whatever the reason, 3I Atlas continued to accelerate outward, carrying its secrets beyond Mars and into the cold silence between worlds. Spectroscopic readings deepened the mystery. As sunlight reflected from the object, instruments detected nickel vapor, shimmering lines in its spectrum, far from the Sun, where temperatures should have been too low for any metal to vaporize. Even stranger, no trace of iron was found. This broke the fundamental nickel-iron pair rule, the observed balance seen in nearly every known comet or asteroid composition. If 3I Atlas contained pure nickel vapor without iron, that meant it was forged under conditions never before observed, perhaps in a supernova shockwave or around a star older than our Sun. Others proposed more exotic explanations: direct metal vaporization through electromagnetic induction, or molecular states that don't exist naturally in our system. Either way, this was no ordinary cosmic rock. It was a chemical enigma, a capsule of alien chemistry that seemed to defy the periodic rules written by our own solar history. Then came another shock. The James Webb Space Telescope observing 3I Atlas as it receded from the Sun, reported a CO2 to H2O ratio completely inverted from every known comet. There was more carbon dioxide than water, a chemical fingerprint impossible for comets born near any warm star. This meant one thing. I Atlas was likely formed in an ultra-cold molecular cloud, far beyond the frost line of any normal planetary system, perhaps in the outskirts of a stellar nursery, or even in the interstellar medium itself. That would make it not just older than our Sun, but potentially older than the solar system itself, a relic dating back over 10 billion years. Imagine that, an ancient shard of frozen gas and dust, older than our own star, drifting for eons through interstellar space, only to brush past our Sun and live to tell the tale. As the comet moved outward, astronomers noticed another bizarre feature, an anti-tail, a narrow stream of dust and gas that pointed toward the Sun rather than away from it. Even more puzzling, the anti-tail seemed to rotate, shifting orientation in ways that standard solar radiation pressure couldn't explain. Harvard astrophysicist Avi Loeb compared its motion to controlled propulsion, like an object adjusting its spin or trajectory deliberately, perhaps through directed outgassing. To Loeb, the idea wasn't that 3I Atlas is an alien craft, but that it behaves in ways consistent with controlled movement. And if nature can imitate technology, or technology can disguise itself as nature, how could we ever tell the difference? For others, the explanation remained purely physical, a complex interaction between solar wind, magnetic flux, and irregular surface geometry. But even that natural explanation hinted at something remarkable. 3I Atlas was more active, resilient, and unpredictable than any comet ever studied. By November 2025, the mystery had grown too large to ignore. The International Asteroid Warning Network, IWVN, launched a global comet observation campaign, mobilizing observatories and amateur astronomers across the planet. For the first time in history, humanity tracked an interstellar object with military-level precision, a dry run for planetary defense. NASA, ESA, and even private citizen astronomers coordinated their lenses to map every flicker, every pulse, every tail rotation. They called it a dress rehearsal for cosmic threats. But to many watching, it felt like something more. Humanity's first coordinated encounter with an ancient messenger, a fragment of another sun's forgotten history, gliding silently through ours. As 3I Atlas drifted past the orbit of Mars and into the outer dark once again, the world was left with questions no one could yet answer. How did it survive the sun's wrath? What chemistry could endure such extremes? And most of all, was this the product of chance or intention? For scientists, the investigation had just begun. For philosophers and dreamers, the mystery had already arrived. When 3I Atlas emerged from behind the Sun, the data it carried wasn't just a collection of numbers. It was a riddle written in light. A riddle that challenged everything we thought we understood about comets, interstellar chemistry, and the very boundaries of natural formation. Trajectory analysis from NASA's Jet Propulsion Laboratory confirmed what many had already suspected. 3I Atlas was not born here. Its orbit was hyperbolic, meaning it would never return. A one-way passage through our solar system from the dark between stars. It joined a very small and mysterious family of wanderers, Oumuamua, 2017, and 2I Borisov, 2019. Yet unlike those two, 3I Atlas was alive with activity, venting gas, glowing in spectral colors never before seen, and resisting destruction in impossible ways. Its chemistry didn't match any known body, and its survival near the Sun placed it in a class entirely its own. Together, these three visitors told a simple but profound truth. Interstellar objects are not rare. We've simply not been watching long enough to notice. Astronomers now believe that thousands of such travelers may cross our solar system every century, undetected, silent emissaries from the birthplaces of alien stars. But what if 3I Atlas carried more than just frozen gas and metal? What if, embedded within its ancient ices, lay the building blocks of life? Organic molecules forged under alien suns? Astrobiologists have long theorized that interstellar comets act as cosmic couriers, transferring complex molecules, even amino acids, between star systems, a process called panspermia. If true, then every comet that drifts through the void might be a messenger of potential life, scattering seeds across the galaxy. And 3I Atlas, with its abnormal chemistry and ancient age, could be one of the oldest couriers of all, carrying within it the molecular signature of a system long vanished into the galactic night. If we could capture just a trace of its dust, a frozen crystal of its interior, we might read the chemical fingerprints of another star, perhaps even another form of prebiotic chemistry altogether. In that possibility lies something profoundly humbling. The idea that life on Earth may be only one chapter in a much older cosmic story. Of course, not every theory rests within the bounds of conventional science. Some researchers, most notably Avi Loeb of Harvard, have dared to ask the forbidden question: what if some of these interstellar objects aren't natural at all? Loeb analysis of Oumuamua and later his observations of 3I Atlas proposed an idea both thrilling and unsettling, that controlled outgassing could act as a form of propulsion, steering an object intentionally through space. Not a comet, but a probe. A silent scout using physics itself as camouflage. The evidence remains unproven, yet the hypothesis has reshaped how scientists approach such mysteries. Future missions may not just analyze interstellar visitors, they may watch for patterns of motion, deliberate maneuvers, or signatures of artificial composition. For the first time, humanity is learning not only how to detect such travelers, but how to question their intent. The legacy of 3I Atlas is already changing astronomy. The upcoming Vera C. Rubin Observatory will soon scan the entire night sky every few nights, expected to detect 1 to 2 interstellar objects per year. Plans are underway at NASA, ESA, and the Chinese National Space Agency to develop intercept missions, spacecraft that could rendezvous with these wanderers in deep space. In a decade, we may no longer just observe visitors like 3I Atlas. We may reach them, touch them, sample them, and uncover the raw materials of another world. For planetary defense, these programs are essential, but for philosophy and science, they mark something deeper, a turning point in humanity's relationship with the cosmos. No longer are we passive observers. We are beginning to engage the galaxy directly, to listen, to study, to wonder. And so, long after 3I Atlas has vanished back into the dark between stars, its story remains. It's a reminder that the universe still holds secrets capable of humbling even our brightest minds. It is both a messenger and a mirror, reflecting how far we've come and how much further we must go to truly understand our place in the cosmic order. Perhaps that is its greatest gift. Not proof of life elsewhere, but proof that mystery itself endures. That curiosity, the same force that drives comets and civilizations alike, still burns in us. Somewhere out there, beyond the heliosphere, 3I Atlas continues its endless journey through the void. Maybe it will cross another star system in 1,000,000 years, Another world with beings who will look up and wonder, as we do now, at a traveler that once faced the fury of a sun,